Hey guys, today what we're going to be doing is looking at power of zero. So this means what are we going to do when we have an exponent that is actually zero? So here's the general rule. Any number or variable to the zero power is 1. So if I have 50 to the zero power, it's 1. If I have x over 2 to the zero power, it's also 1. So we're going to use this general train of thought to solve some of these problems. So let's go ahead and look at this first one. What this is saying is some number to the zero power to the second power. Well, if I work from the inside out, x to the zero power is 1, and 1 to the second power is also 1. You can also think about this as a power to a power. 0 times 2 is 0, and anything to the zero power is 1. All right, now looking at this, I have -5 to the zero power. Now this one's a little tricky because it's -5 to the zero power, and that negative is not included. So this is saying negative, and then 5 to the zero power is just 1. So this just simplifies to -1. So when we apply this for a few more exponents, what this is going to look like is I have 10 times x to the -2 divided by 2 times x to the zero power. Now looking at the denominator, since I have this entire 2x is taken to the zero power, the denominator is just going to be 1. So I'm going to have 10x to the -2 power all over 1. And now what I notice is I have this x to the -2 power. I'm going to move that from the numerator down to the denominator. This will give me 10 all over x to the second power. And there's nothing more I can do there, so that is my final answer. Now looking at this one, I'm going to look at combining lots of rules. Negative exponents, things to the zero power, so on and so forth. So the first thing that I notice is I have this r to the zero power. Now remember, anytime I have anything to the zero power, that turns to just 1. So now currently I have r to the -3rd power, s to the second, all over s to the -4th. Now what I'm going to do, there's a few ways how I can go about solving this one. And what I like doing is I notice I have a few negative exponents, r to the -3rd and s to the -4th. As a reminder, anytime I have a negative exponent and it's on the numerator, I'm going to move it down to the denominator. And also, anytime I have a negative exponent on the denominator, to make it positive, I make it to the numerator. This looks like s to the second, the one that doesn't change. Then I'm going to have s to the 4th. It is now positive because I moved it from the denominator to the numerator. And r to the 3rd. It's positive because I moved it from the numerator down to the denominator. Now we just remember our old rules of I have s to the second times s to the 4th. That'll reduce to s to the 6th power all over r to the 3rd power. There's nothing more I can do there, so it stops right there. Now I like this one. This has a lot of big numbers with a lot of variables with a lot of big exponents. That's taken all the way to the 5th power, taken all the way to the zero power. So on these, we're trying to trick you because you're trying to look at what I do in here, and then I have a power to a power, so I'd have to distribute it all here to each and every one. And so I'm going to have really big numbers. But I want you to notice that everything is taken to the zero power. So whenever I have all this junk on the inside, it's important to realize it's taken to the zero power. Because remember, anything, including all of this, is taken to the zero power. Therefore, my answer is just 1. Because anything taken to the zero power is just 1. Now looking at this is one of those problems where I have a lot of stuff going on here and I need to figure out what is being taken to what power. So the first thing that I like doing is starting with my zero powers. I have this x to the zero power. That means that simplifies to just 1, so it almost kind of just cancels out because 4 times 1 is just 4. I'm then going to look at my numbers to see if there's anything I can do here. I have 4 divided by 4. 4 divided by 4 is just 1, so those also just cancel. Now I'm going to look at my negative exponents. Anything that is negative is going to move down if it's on the numerator, and anything on the denominator is going to be moved up to the numerator. So let me go and start with this then. I have this orange x here that I'm not touching. But this y to the negative 1 is going to get moved up, and that's going to be y to the first power. This z to the negative 3 is going to be moved down to z to the third power. And this y to the negative 2 is going to be moved down, so that it becomes y to the positive second power. I now am going to look for common variables. I have y to the first divided by y to the second. So what I'm going to do there now is I am going to reduce those, and that will leave me with x to the on the bottom, z to the third on the bottom, and y. There's nothing left on my numerator, so I'm going to put a 1 right there for my final answer as 1 all over x times z to the third times y. Alright guys, I hope these videos helped. If you have any questions, please feel free to email me or your teacher.